Today I would just show you as much as possible about PDW, what it is. A couple of months ago we released a new product, the version 2, based on SQL 2012. And hopefully if you walk out of the room you have a good understanding of what the product is about, why it's such a great product, and what you can do with it and what it will bring to you. So I will talk about the architecture. It's an appliance, so it's a little bit different as the way you used to work with SQL Server. Some really interesting new features, like the updatable column store is already part of PDW, so you can benefit from that today, and just a whole bunch of demos. Well, before I get started, maybe a quick introduction of myself. I have a really long history of optimizing SQL Server implementations. I run a performance lab for Unisys for 10 years. Now I optimized like databases like crazy, right? And back in 2002 I built the largest SQL data warehouse in the world. It was based on SQL 2000. It was 17 terabytes, like 17 terabytes of image data. It was all financial payments floating around in Holland. And actually fully redundant, and it made it into the Winte top 10 as the largest implementation in the world. But since then I thought, well, like with every major release of SQL, I thought, well, let's do something crazy and see if I can come up with something fun, right? So I don't know if any of you still remember the project Real, like a whole set of white papers how to build a data warehouse. It was based on the Barnes & Noble data. With the launch of SQL 2008, the ETL world record, like data loading really fast. I wrote and contributed to a lot of SQL white papers. But then at some point I thought, okay, all this performance optimization, been there, done it, seen it. So I switched to a completely different company, and it was like in Holland, where I come from, a company called Schubert Philips, and they offer mission critical BI solutions, so they host these solutions. They provide in written 100% functional uptime in the SLA. So to build a solution end to end that is always on, always up, that was pretty interesting to learn how to run a data center. But then in April 1st, 2011, I got an email saying, hey, we're starting something new with SQL Server. It's a new chapter when it comes to ease of use, to performance. How about joining Microsoft and spend your time on SQL Server PDW? So that's a little introduction of me. Yeah, I'm like a volunteer for the PAS community since early 2005, where I did a lot of performance testing with the dev team in Redmond to optimize SSIS. Yeah, so hopefully today I can share some of my findings of the last 2 years working with PDW. But just for fun, the first SQL Server I worked with looked like this. It was a 32 CPU machine, 64 gig of RAM. It had like Pentium 3 CPUs in there, and you could run either 32-bit or Itanium CPUs in there. Now, the reason why I'm showing this picture is like a lot of stuff happened since then, right? When it comes to performance of SQL Server. Like, does any of you remember what was the major performance booster of SQL 2000? Nobody? Well, there was this little tick box called AWE, right? So you could run your buffer pool in memory, and you could query, you run your queries faster if you query the data from memory, right? So today everything is about in-memory processing. But the reality is SQL Server is using from every single bit of memory that is in the box for many years, right? Okay, well I will challenge you a bit more then. With SQL 2005, what was the major performance booster in SQL 2005? Come on. This is the SQL community, really, right? Yeah. It was table partitioning, right? And you probably all use it today, right? So with table partitioning, you were basically limiting the range of data that you have to pull from disk to run your queries, right? Okay, next one. SQL 2008. What was the performance booster in SQL 2008? Really know it. Page and row compression. So you could compress the data and store it more efficient on disk. With SQL 2012, we have the read-only clustered column store. And with SQL PDW, we have the updatable clustered column store. And also the ability to stripe the data across many compute nodes. Right? So, back in the old days, like if you want to scan data with like over 3.5 gigabytes of data a second, it would take 42 fiber cables, 42 HBAs, like over 250 spindles to get to that scan speed. But reality is that now you saw it in the keynote, that the world is changing. We have so much more data that we basically cannot afford spending time in rebuilding indexes all night long, optimizing, running, adding queries. So we need a different approach to scan through data faster. Maybe the last question, like if you purchase a server today, like does any of you have an idea of how fast you can scan data in memory? Everything what's in memory is fast, right? But does any have a number? I will buy a drink if you know the answer. Well, like if you purchase like an entry-level server, right? You can expect like 25 gigabytes a second scan speed, right? So I've asked my wife or mentioned this number to my wife, and she said, "Well, is that a big number?" I said, "Yeah, it's like 6 DVDs a second worth of data that you can scan in memory." If you purchase a really big server, the high-end servers, you can reach up to 60, 70 gigabytes a second. So all the analytics, what we're talking about today, scan speeds per server, is the contribution there is the hardware contribution is well, make it between 25 and 50 gig a second. So all stories we talk about, scanning terabytes, petabytes, zettabytes of data. And so we need a different approach to scan through the data faster, right? So with PDW, I don't know if any of you have seen this movie from the past summit in 2012, where we demoed scanning a petabyte of data within a second. Now, if you talk about what's a petabyte of data, right, then it's a lot. But if you do the maths real quick and you see, well, this was a 40-node machine, so the data was pulled from 40 servers in parallel, and you do the maths real quick, what's the scan speed per second? It was a great lunch, but it's roughly 25 terabytes a second, right? So if you have a petabyte of user data, you throw it in PDW, you run a query, and you select a couple of columns, you do some order bys, group bys. Within a couple of seconds, you have the response. Yeah. So basically, the whole discussion about in-memory processing has nothing to do with the fact that the data resides in memory. It all has to do with how fast are the algorithms to scan the data in memory, and how efficient can you scroll to the data in memory. Now, if you want, for example, a good indicator of how much data you're processing under the hood in your SQL server, if you go home and you look at the Windows performance counter, it's called page lookups per second, you multiply that by 8 kilobytes, then you have an idea of how many blocks of data are processed every second in your SQL server, right? So it's a good indication on how busy your box is. So with that, I would just give you a quick introduction of PDW. I've been tuning and optimizing SQL for over a decade. And basically this was all about scaling up, right? Extra CPUs, extra memory, more and more CPUs, faster hardware, SSDs. We shifted from 32-bit to Itanium to x64. But every time, if you need more capacity, you had to purchase a bigger box. Right? And on top of that is the way we store the data in SQL Server today, right? All these pages. That's if you want to grab data from a page, right? You have to load these pages and just search for the data that you're looking for, and basically you throw away the rest of the information. And of course, you can build an unclustered index extra and have that optimized to get higher scan speeds. But the reality is that we were looking for a new way to scan through the data much more efficient than we do today. So PDW is all about basically addressing 3 areas where we see that the customers are struggling. Right? It's if you have to scale your environment, so process more and more data, store data, do it a little bit cost efficient. Then we need a different approach to scale the data across multiple servers seamlessly, right? And also, like Jim mentioned, we have more and more different flavors of data to work with. So PDW, it's basically an appliance. So it's a pre-built, pre-configured, pre-regged, pre-everything solution. You just purchase an appliance, like you purchase a mouse or something. Okay. And you can give Dell a ring or HP, and they will deliver a PDW appliance on your doorstep. It will be powered up, network will be configured, and you're good to go. So the time to build a data warehouse that is up and running, and that is running at top speed from day one, is significantly less than the traditional data warehouse implementations that I've worked on in the past. And you can scale from 2 SQL Server nodes all the way up to 56 compute nodes, right? So that's more than enough for the next couple of years. And also if you power up the appliance, if you talk about SQL Server performance, and you just confirmed it a little bit, right? If you power up a server, nobody has a clue anymore on what that hardware is capable of, right? You assume it's fast, you assume the more memory, the better. But to have a good understanding of the workload that box is capable of is so different and difficult to set up that we need a different approach. And I think an appliance is definitely keeping up to that promise. And also, if you power up the appliance, it will run an health test, and the check will figure out everything. The scan speed for memory, copying data in memory, all the networking, the disks, everything is checked, and then you get the green light, and the appliance is good to go. So basically, the concept is traditionally, if you have a server back home, you spend your time optimizing the storage, right? There's another session going on, how to optimize your file groups, how your files, everything. And at the end of the day, the way forward is to strike your data across as many databases as needed, and also pull the data in parallel from all these appliances seamlessly, all these instances, and just benefit from the speed. So the concept, if you have like a large fact sales table, you just slice it and store the data across all these compute nodes. Of course, you can also store a full copy of like dimension tables on each of the compute nodes to run some queries, although it might sound a bit contradicting to run it a little bit faster, but I can cover that later if you want. So the concept is A base unit PDW is just 2 servers. We have storage pre-configured, pre-installed, there's a hot spare, and there's a node for housekeeping. If you power it up, this all works as a single SQL database, and I'll show you that in a second. But the good thing is, if you need more capacity, you just give Dell or HP a ring, and they will provide a scale unit, extra block that you add to your PDW appliance, and yeah, you can grow all the way up to 6 petabytes of data, and expect more to come there in the next couple of months. Yeah, so under the hood, and like it's level 200 session, right? So I'll just touch briefly on this. Is if you fire a query against PDW, actually what's new is that the secret sauce of PDW is that if you query a table, that under the hood, instead of like one large table, you're querying like 64 smaller tables, and that query plan, that's an extra query plan on top of the regular SQL SMP execution plans, and that's all done in the control node. I will show you later on. But the absolute best thing of PDW, and that is, like I mentioned, I've spent my life tuning and optimizing everything possible. With PDW, we already have the updatable column store. So it will be also available in SQL 2014, but it's already in SQL PDW. And it is so much faster out of the box because we slice and store the data in segments on a per column basis in chunks of like 1 million rows. And so the amount of data that we have to scan in memory or reload from disk is only a fraction of what it used to be in the traditional data pages. Right? So it's a completely different approach on how the data is stored and pulled. How many of you already played around with SQL 2014 and the CCI? Just 2? Okay. Okay, then it's time to demo. Well, okay. So that was a little bit of introduction of the concept, how it works, how we get the scale and the speed. But maybe it's better if I just demo this and show you the differences. So, data loading. If you remember my introduction, right? A couple of years ago, I set the world record data loading, 1 terabyte of data, loading it into SQL in 30 minutes. But the reality is that I had to chop that 1 terabyte into 56 smaller chunks, start 56 bulk inserts to get the performance right. So with PDW, you can just read a single file and write it into PDW significantly faster than with a SQL Server. And SMP stands for Symmetric Multiprocessing, and MPP is Massive Parallel Processing. So I would like to demo you as an example, like loading a single flat file, 75 gig of data, 600 million rows. How long does it take to load a single flat file into SQL? Anyone? Any number is good, just 75 gig, right? That's a couple of DVDs. Okay, I will demo.
45 minutes.
So I logged on to a pretty beefy server. It's a DL580 with 32 physical cores, hyper-threading enabled, 256 gig of RAM, and it has 2 EMC high-end VNX, 7500 something, with flash drives, 100 SAS spindles. And so this is how you would typically run your SQL Server today. So if I say, well, let's bulk insert, and the file that I will bulk insert is here. Yeah. It's this file, line item table. It's 75 gig of data and 600 million rows. Right? So typically you would use either SSIS or the traditional bulk insert. right? So I will read from the line item file and dump it into a SQL Server. Now, if I open Task Manager, the first thing you notice that it's not using and utilizing all the CPUs, right? It's just a single CPU that has to do all the work. If you go to the Windows Perfmon and look at the disk read bytes per second, see I'm reading that 75 gig with, say, 17 meg a second. That's megabytes, right? Not gigs, teras, megabytes. So, if you look at the SQL Server processor time, I'll just clear it for a second. I think some colleague is running another demo. Yeah. Well, but you would see typically it's one CPU, like 100% utilization for SQL Server to process. So with the 64-core machine, you can go up to 6400% of CPU, but typically a single bulk insert is like this, 100%. Right? So bulk copy rows is like, make it 140,000 rows per core per second. So we have 600 million rows to go. Any of you who's good in maths, big data? No. But expect this will run for at least 1.5 hours. Right? So the only way to speed this up is chop this file into many smaller chunks and start many bulk inserts in parallel. If you want to have a look on how to do this, on my blog, henkvandevalk.com, I wrote an article that just picks these tasks from a work queue and fires off bulk inserts in parallel. But the reality is that this is what you get from a SQL Server, right? It's a single bulk insert, it's running, and it will keep on going. So with PDW, we thought, well, this is moving data from A to B is the typical pain point in the industry, right? Moving a couple of gig via internet is tricky, right? So I will switch over to a PDW appliance, and I will create a database. And you see what's new here is that I can specify a distributed size and a replicated size. So the distributed size is I allocated a terabyte of data to store data that is striped across all the compute nodes. And this demo appliance has 8 compute nodes. And so that means that all the data is surfaced on 8 separate servers under the hood. And each of these servers have like 8 what we call distributions. Yeah, so under the hood, the data is stored in 64 separate tables that have their own, each unique set of spindles. So querying this data is basically querying data from 64 tables in parallel. So if I create, say, a new table, and let's create a heap. I have to specify something which is new. This is a distribution key, so I have to pick a column and use that to stripe the data across all these compute nodes. So let's switch to the database I just created. Where is it? Really? So I created this table, but just for fun and for the sake of time, I will also create a native clustered column store index-based table. So this is this new storage type that I mentioned. So instead of clustered index, you specify now clustered column store index, right? New word. And the bulk insert utility of PDW, the BCP utility, is called DW Loader. And I will read that same flat file with 600 million rows. We'll use the fast append mode. That basically means lock the table, throw the data in as fast as possible. And also have other options like reload the data, truncate table and start all over, but I can also append data. So if you have an existing table, you can append data really, really fast at the bottom of the table, and you only lock the row that you're inserting. So you can still query the table while inserting new data. And also we support the upsert command. So insert or update, and you can there pick a column, and based on the value in that column, you either insert or update. So I specify the IP address of the PDW appliance. I specify this new segment size of 1 million rows per segment. If I have more than 100 rejects, I'll stop. Put all the rejects aside if they show up. Field separators, end of line separators, username, password, and the new SQL Rally CCI table that I just created. Copy. So I have this same file, and let's give it a try. Yeah. So I just kicked off the same task, right? To see the SMP box is running the bulk insert, and PDW is running the DW loader utility. So if I switch back to the other box, and PDW comes with an admin console, so it has the same look and feel as your Azure interfaces, right? So you can see what is happening on the appliance right now. So you don't need any special DMVs to run, it's there in admin console. So the task that I just kicked off is running. And like within 37 seconds, I already loaded 56 million rows. Right, so for those of you who do the maths real quick, 600 million rows will mean like 5.5 minutes. Right? So SMP, 1.5 hour, PDW, 5 minutes. And yeah, the magic is that the data is written into these 64 tables in parallel. And so we have these 8 compute nodes, and they're all handling their chunk of the data. And like if I zoom into one of them, you see that all the mount points, right, all the LUNs, have their share of the data. So in PDW, writing out the data is faster than the speed of how fast I can throw the data at PDW, right? So that's completely the other way around with SQL Server, where writing is typical the Achilles heel, right? Okay, so let's switch back to the bulk insert, still running. Okay, going strong. Okay, how about I'll just switch back to the I documented everything I just showed you, just for fun. And we'll get back to this later on. But basically, if we look at the results, right? If you compare SQL 2012 to SQL 2014, and I was running some experiments, and I noticed if you load data into in the CTP2 into a heap, and then build the CCI table on top of that, the clustered column store format, it is significantly faster than if you do similar as in PDW, where you just create the CCI table as the native format and dump the data straight into the CCI, right? So with SQL 2014 it was close to 3 hours to load this file, and with PDW it's just a couple of minutes. And actually loading into the CCI was faster than loading it into the heap. And that is also yeah, interesting. Yeah, so bottom line, PDW loads like this single flat file like 15 to 36 times faster than your SQL Server back home today. Also, if you load the data via SSIS, we have a special destination adapter that basically helps to bulk insert the data in parallel. And there it takes 33 minutes to load into a CCI. So that's roughly at least 2.5 times faster. And so switching over to and write the data to PDW with your existing SSIS packages is at least 2.5 times faster. So if the nights are too short, it takes your ETLs takes 14 hours to load. If you go to PDW, it's 5-6 hours. And of course, if you take the time to rewrite the bulk insert routine, just pick the data from flat files, and then you get 15 to 36 times the improvement. But actually, most customers are already happy with a 2.5x improvement. Yeah, and these modes, right? Append, reload, observe, and fast append. So that was sweet spot number 1, data loading. Now the second, the one I really like best is query performance. Right? If you query data in an SMP machine, like I mentioned, you have to query all these pages of data, and with PDW we have the clustered column store. So I just prepared some comparison demo. I have the same database stored on SQL 2012 and stored on PDW, and I will just run side-by-side comparison, querying. Like I have a fact sales table, which is like 1 billion rows and roughly page compressed 500 gig of data on disk. And I've been cheating, so the data is preloaded in cache, in memory. Like all the demos I will show you are more or less running in memory. But as you see, right, to run a count star on 1 billion rows, it takes like, well, roughly 4 seconds to scan through 500 gig in memory, right? So page compressed, you get up to say 100 gig of user data that you can scan. Now, so with all the queries, I provided the cold cache results and the warm cache. Right? So if I have to load this 500 gig from disk, it would have taken a minute. And with the data in memory, it's 4 seconds. Now, if I would like to query this fact sales table with 1 billion rows and just figure out how many products I've sold per calendar year, then it's pretty straightforward. But it's already, we're talking like 22 seconds to run such a basic query, right? So is it good, is it bad? Well, it really depends, right? If you have users who sit and work on analyzing data mining, they want to get insight really, really fast, and then 22 seconds might already be a little bit too much, right? Well, min-max, also 17 seconds. If I run a query, like I would like to understand how much of what I've sold per state, group by, order by, well, I can run this query. But basically, I think you get the picture that even if you query like 1 billion rows worth of data in a table, you're already talking seconds or minutes to query these data sets. Right? So if we grow and grow with more and more data, and probably you all hit these numbers, like 1 billion rows now these days isn't that much anymore, right? People tend to keep more and more data in the data warehouse. So we need a smarter approach to scan through that same data significantly faster, right? So I will just stop that one because it will run for a couple of minutes. But this is my favorite query. Like, if I would like to understand how much, what I've sold in the year 2008 versus the previous years, scanning that same 1 billion row fact table, you say it takes 12 seconds to get an answer, right? There's a group by, order by, and actually that's pretty good, right? That's a new high score, 12 seconds.
Question.
Yeah.
You're supposed to have the dimension tables in the in each node replicated. That's the way it works.
Yeah, but this is an SMP machine, so everything is on a single box.
Oh, this is still the SMP.
This is the SMP machine, right?
Oh, I thought
so I will show you again. If I run this query, Go. You see I'm firing up all the cores.
Mm.
Yeah. And if the query is complete, right, the machine is back to rest. But this is all data that is preloaded in memory, right? And if it's not in memory, it can take minutes to get the data.
So it's the case if you have the MPP box,
Yeah.
then would you need to have the dimensions replicated on?
So I will quickly show you.
I'm taking over the agenda, I'm sorry.
Yeah, I'll quickly show you. So I have the same database and stored it in PDW in the new clustered column store format, right? So, oh, sorry. So I can I will just copy this stuff and take it, throw it in here. So if I scan that same table, and if I run a PDW, DBCC, PDW show space used on this fact sales table, and actually under the hood I'm querying 64 smaller tables with just 300 meg worth of data. Right? So that 500 gig of page compressed data in an SMP machine is basically like 64 times 300 meg on disk in PDW. So if I then run a select count star, like scanning a billion rows takes well, less than a second. And for example, if I go to 10 billion rows, oh, I get an error because I need to switch to account big, right? So I can scan a billion rows like within a fraction of a second. If I run the same query, like how many products did I sold per calendar year, like I get a nice response also within seconds. Min max, well, no, 4 seconds, not bad. But this query 4, right, that runs for like a couple of minutes on an SMP machine, completes within a second on PDW. Now, if I run my favorite query, number 5, on PDW, you see it responds within a second. But if I, instead of querying like 1 billion rows, if I switch to 5 billion rows, and again, see, it takes 2 seconds to scan 5 times more data. So I hope you get a little bit of an understanding of running queries, right, in PDW with the distributed approach and the significant higher compression ratios of the CCI, that you can query the data much faster. So to answer the question on this fact sales table is at the moment distributed across these 64 distributions. Yeah, and the dimension tables are replicated, so they're all also CCI format, but we have a full copy on each compute node. So I was thinking of, like, one of the questions I get most is, well, how does PDW performance compares to SQL 2014, right? Because it's the same technology. So what to expect there? So what I did is I took this 1 billion row fact table and I distributed it and stored a full copy on all 8 servers. And if I run a query against that replicated table, then basically I get the performance of a single node in the appliance, right? So if I run a select distinct, and so it's what's called CCI replicated. Yeah, so if I run this one, I did the maths already, right? So an SMP machine will take 2.5 minutes. And a single node, like, which might be comparable to SQL 2014, is 27 seconds, and PDW is 1 second. Right. So that gives you a little bit of an impression of why I don't spend my time on performance optimization, but second is a second, right?
Just a question.
Yeah.
Do you replicate the small dimension tables manually, or is that done automatically?
Now, if you create a table, then in the bottom you specify the clustered column store index. And if you don't specify a distribution key, it will automatically replicate the data across all the compute nodes. So the default is replicate, unless you specify you want to distribute. Yeah.
And also the dimension tables to replicate the complete dimension.
Yes, so if you don't specify the distribution key, then it will replicate. Okay, so 27 seconds versus the I'll show you. So this is reading from 64 tables in parallel. See, then you have a second response time. So let's sweet spot query performance. And that was basically one, importing data, two, querying the data, but number three is exporting data, right? So if you want to write data out of an appliance or out of SQL, that's typically an area where not many people like to talk about, right? We have the BCP out command. We can use SSIS. I've figured out a trick to speed up reading like 3.5 or 2.5 times faster, 3 times. But basically with PDW we thought, well, wouldn't it be great if we can write data out of PDW, like we have all these distributions, and bulk write all this data out to a separate SQL box. That feature is called remote table copy. And basically, if you say create remote table, you specify the SQL Server destination. You specify you have to provide the data source the destination. If you want a port number, and then you specify the data that you would like to export, like select star from SQL Rally line item. So what happens is in the background, each distribution will be copied out in parallel to this SQL Server machine. Now, I started my demo with showing you bulk inserting, right? So you have single file, single bulk insert, single CPU. And with the remote table copy, we leverage the full capacity of that SQL Server box. So actually, like I mentioned, if I import the data with bulk insert into SQL, it takes 1.5 hours. But if I load that file into PDW, it takes 5 minutes, and then export it via remote table copy, that takes 25 minutes. So if I want to load data into a SQL Server box today, absolute fastest, and I'm not allowed to touch the source file, as some customers come up with these crazy IDs for POCs, then actually loading into PDW and exporting is done in 30 minutes. And so using PDW as staging is providing you parallelism. Who cares? Yeah. Also, if you want to write data out fast, right, you can just specify SQL command. You specify you want to read from your PDW appliance. You say 2 dots out to a text file, and then go select star from time or something, and you just write the data out to a flat file. So depending on the speed of your the destination, expect 50 gig a second. 50 gig an hour in writing out to a single flat file. Yeah. Okay, sweet spot number 4, Hadoop integration. Like, how many of you have worked with Hadoop before? A couple. And if you query, do you have any numbers? Like, how fast can you read data from Hadoop and write to Hadoop?
Slowly.
Slowly. Okay, but if I assume you have a 1000-node machine at home, right? No. what we added to PDW is a feature called PolyBase, and it was developed by Dave DeWitt from the Gray Labs. And the first couple of versions he threw away. And this version, PolyBase, is really, well, I really love it, because if the way it works is very simple. In PDW, you can create an external table. That's the metadata. That external table points to a folder on a Hadoop file system. And if you query that external table, then PolyBase or PDW will go out and just read from the Hadoop file system the blocks it needs. So it doesn't need MapReduce functionality to grab the data from an Hadoop file system. So traditionally, if you want to query Hadoop, you need like MapReduce, like if you run a select count star from Hive, you get like 3 MapReduce functions, and it takes 50 seconds before you get a response. And with PDW, we grab the data from the blocks directly, and it's really fast. So end users, they can query data that resides in Hadoop without knowing how to write MapReduce functions. And yeah, PDW handles the complexity there for you. So how does it work? Well, traditionally, I don't know if you heard of the scoop connector, but if you want to pull data from Hadoop, you can already do that with SQL Server today. It's called the scoop connector. And basically you open a single connection, and the throughput of that single connection, that is the rate how fast you can grab the data. Now with PDW, on each of the PDW compute nodes, we have a service running. It's called the data movement service, right? The secret sauce of PDW. And the data movement service can open up a connection to each of the compute nodes or the data nodes in Hadoop, and grab the data by itself. So it doesn't need to go via the front door. It can go via the back door and grab the data really fast. Well, maybe just quickly show you this. So, how does it work? SP configure, Hadoop connectivity, _1, reconfigure go. And so if you select a database within a database, you can specify like external tables. So I think it's pretty unreadable for you in the back. But here we have a folder called external tables, and if you click on it, you'll see an overview of just delete this one. You can see the external tables that point to a folder in Hadoop. So if I run select star from sys external tables, I get an overview of the external tables. So just as a demo, how about reading data from PDW and write it to Hadoop? Right, so I can say, well, create an external table. So I added the word external. Specify the Hadoop file system location, so IP address, folder name, and the folder name where I want to store my data, subfolder called dim customer export SQL ready. I have to specify a field terminator for the flat file where I will push the data into. And then I just say select star from dim customer. And now I just read data from PDW and wrote it to Hadoop. If I would like to query this data, I can just run a regular query, select star from dim customer, where customer ID is something. Yeah, and via the metadata, I'm querying flat files that is stored on Hadoop. Right? Now, if I wouldn't have used the name Hadoop here, you wouldn't have realized that I was grabbing the data from somewhere else. Right? And some people normally say, well, this looks like a link server. Well, I think it's much more than that, right? It's really fast, and it combines both worlds of the structured data world and the Hadoop world. Oh, so if I create an external table, like you're used to, at the end, what's new is you can specify a location, date formats, reject types, and so on and so on. And you can just, the folder name doesn't exist. So you can just create a folder on Hadoop. Also, if I would like to import data from Hadoop, I can say, well, create a local table, right? Create a table. I specify the distribution like replicate, right? Like copy on each of the compute nodes. And I run a select star from my source data. Where is it? Renaming dim customer Hadoop. And now I just read data that resides on Hadoop and imported it into PDW. So if I now would like to query that data, run select star from SQL ready, and I'm reading from my local copy of the data that I just imported. And so it's pretty smooth. You can query, write regular T-SQL queries, and you can mix and match data, and the end user doesn't even have to know where the data is stored. Right? So I hope that gives you a little bit of insights. Well, I have a couple of minutes left, so I'll skip the rest. But I hope this gives you a little bit of information on Hadoop. Yeah, and the bottom line is, of course, if you have a regular Excel sheet and like you want to query your data, you can just mix and match from PDW and Hadoop. Another really fun part is Rollup. Like, how many of you are building cubes? Ah, that's better, that's better. How many of you use Rollup? A few. So traditionally, you pre-process your data in MOLAP cubes, right? So that means you read all the data, do all the aggregations, and store the results in your cube. But I have customers who spend like 36 hours on refreshing their cubes, right? These are, well, multi-terabyte cubes, and you can spend hours on that. But the good thing is if you switch over and read that same data in MOLAP from PDW, traditionally, what I've seen is like, because you read the data in parallel, processing that same cube data is like 3.5 times faster. And so that customer was processing cubes for 36 hours, completed in, well, 6-7 hours. And so if the nights are too short to process your cubes, just think of PDW, and the MOLAP is much, much faster. But also in SSIS 2012, Service Pack 1, there's a new feature called Run Distinct Count on the database side. And so you can push these Run Distinct Counts to PDW. PDW will do the number crunching for you. You just store the result and provide it via the cube. So what does it bring? Well, just start one more time. If I open up an Excel sheet and I connect to a Rollup cube, it's the same data that I've been querying, like I have the distinct count, product. Let's pick the 5 billion rows as well. Let's look at all the fact sales. So, sales amount, I don't know. Let's select all the stuff. The fact sales, the 5 billion rows, customers. Let's see what's happening in Europe. Well, what shall we look at? Like, I'm from the Netherlands, so let's pick Netherlands. What's happening in the north? Amsterdam. Yeah, so you see this is Rollup mode. So I'm querying a 1 billion and a 5 billion row table in PDW, without pre-processing a cube, right? So I just have the metadata in my cube, and I just grab the data. So this is what we call the ad hoc analysis. Just looking into, I'm looking for insights in data sets, you know, a couple of billion rows is peanuts for PDW. Okay, so if you want to, the setting is called enable rollup distinct count on data source equals 1. So if you want to enable it, here's where to look. I think the last demo for today is ad hoc query concurrency. So how does SQL Server work today, right? If you fire off a query, what will happen? That if it's a huge query grabbing a lot of data, by default it will get like 25% of the memory assigned to run that query. And so if you have a couple of very demanding queries, then you can imagine if you run 3 of them, 3 will run, but the 4th will end up in status runnable. Right? If you open up Activity Monitor, you will see that the number of queries that run in parallel on the SQL box is pretty limited. So what can you do there is enable the resource governor, trim down the max memory granted per session to say 10%. Then you can run 10 in parallel. Right? So with PDW, I think that one of the best features is that you can run many heavy queries in parallel, and the box just keeps on going. So just for fun, I took that query number 5 with like the billion rows. I'll take that one. And yeah, just for today, I prepared a demo with Postgres. So we'll fire off reading that query 5 and fire it off 10 times on the SMP box. As you can see, it's maxed out 100% on the box. Yeah, the queries are running. And let's do the same for PDW. And I will run the same query, but instead of 1 billion rows, let's run 5 billion or 10 billion? 10? Make it 10. Call it here 10. Okay, save. We'll change the title, very important for the demo. Yep. And instead of running 10 queries, I will fire off 20 in parallel. Let's have a look at the admin console. You see all 8 servers are fully maxed out, 100%, so the box is really busy. The SMP machine is also running. Okay, let's see who's going to win. And just as an example, like last year at SQL Rally, I demoed PDW V1. So if you had a V1 box without the clustered column store and like 10 nodes, if I was running a load test with 200 concurrent users, firing off like 400 really complex queries, it took like 10 minutes to complete them. And with PDW V2, if I just start with a base unit, which is just 2 SQL servers, I can run the same load test, 200 concurrent users, and instead of 400, I can run like almost, well, over 1100, almost 1200 queries within the same 10 minutes. So PDW version 2, like you need less hardware, and it's faster than the V1 version that I demoed last year. So I hope that gives you a little bit of an idea of what PDW is capable of. If you want to read more about PDW, we just finished a really nice white paper. If you want to read a bit more on all the differences, what I just showed you, SMP versus PDW, it's the second one, a new white paper. But if you just go to microsoft.com/PDW, that's the landing page, and from there you can grab all the information. If you want to know more about PolyBase, what's happening there, and link. And I think really important is that PDW has the lowest price per terabyte in the market. So if you compare all these appliances out there from the competition, I think with PDW we have done a really great job to keep the cost down as much as possible. And there's a white paper on that. So, to me, PDW, it is an appliance, which is a completely new approach, right? You don't spend your time anymore on tuning the SAN, tuning the network, tuning SQL, file groups, all the stuff, index maintenance. It's just an appliance. It's a data warehouse appliance. And yeah, if you need more capacity, like if storing a couple of hundred tera is not enough, you can go up to the petabyte range if needed. But what's really interesting, and I think also for you, right, it's a really steep learning curve, right? I've never been trained on PDW myself. I just get started, and like within 2 hours, I was had my data loaded, run the query. So it's really simplified. You can run a data warehouse at scale, and it is really fast. And if it's Microsoft single point of contact. So to me, PDW is really all about speed. So my favorite question, if I go to a customer and say, well, if I can query all your data within a couple of seconds, what is it you really want to know? What would you do next, right? And I think that is the game changer, what PDW is capable of. You can query all your data and it's at your fingertips. So I hope, let's switch back to the load test. PDW completed, 59 seconds, and the other one, 2 minutes, 5 seconds. Okay, so twice the load, 10 times the data set, and twice as fast. So with that, I hope I gave you a good overview of what PDW is capable of. And hopefully next year somebody of you is here on stage to talk about your experiences. Okay, any